All right, so let's continue with the chapter 6 test review. So we're almost done. Find the values of the variables, then find the side lengths of the rhombus. Okay, so if this is a rhombus, and what specifically are we looking at the rhombus? We're looking at the sides of a rhombus. What do we know about the sides of a rhombus? Sides of a rhombus are all congruent. Just like what other shape? Squares. So guys, please remember to review that big chart that we took a picture of. The angles, the diagonals are congruent in what? A square and a rectangle. The diagonals are congruent in a square and a rectangle. The diagonals intersect at 90 degrees inside of a square and a rhombus. 90 degrees. The diagonals bisect the opposite angles in a square and a rhombus. Okay? And what else? All the sides are congruent in a what? In a square and a rhombus that we just talked about, and all the angles are 90 in a square and a rectangle. Okay? So please make sure that you guys review that. Also, every single property for parallelograms that we just talked about, like in the previous sections, in the last video we did about the chapter 6 test review, all of those properties about parallelograms, the fact that the opposite sides are congruent, the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, adjacent angles are supplementary, and the diagonals bisect each other, all of those are prevalent inside of these shapes as well. Okay, so that was a little review. So let's go back to the problem that we're doing. Find the side lengths of the rhombus. Well, I know that all the sides are the same, so let's set them equal to each other. So I have that 4x minus 6 is equal to 18, and I also have that 6y is equal to 3x. So I'm gonna do this one because I only have one value of x. Instead of this, it has a y and an x. So plus 6 plus 6, 4x equals 24. So x equals 6. So now I know if x equals 6, I can just plug that into here and find my y. So 6y is equal to, what's 3 times 6? 18. Divide by 6, divide by 6. Y is equal to 3. So my x should be 6 and my y should be 3. x6, y3. The length of each side is what? Let's plug one of them in. It doesn't really matter which one, right? Because look, this, if I plug in x over here, what's 3 times 6? 18. And we know that all the sides of a rhombus are congruent. Oh, we didn't even have to do that. Look, if this is 18 and a rhombus is all sides congruent, then I know all of this is 18, 18, 18. So my answer should just be 18. Okay. Find the values of the variables, then find the side lengths of the squares. So once again, side lengths, they're all congruent. So let's put them equal to each other. So I have 3x minus 13 equals 3y minus 10. I also have y minus 2 is equal to 2y minus 6. So I'm going to solve this one because it has all y's. So minus 2y minus 2y plus 2 plus 2, negative y is equal to negative 4, so y is equal to 4. So now if y is equal to 4, okay, let's find our x value. So now we can plug that into this y into right there. So we're going to rewrite 3x minus 13. What is 3 times 4? 12 minus 10. So 3x minus 13 is equal to what? 2. And now plus 13, plus 13. 3x equals 15. So x is really equal to what? 5. So my x should be 5, my y should be 4. X is 5, y is 4. Now the length of each side, let's plug in one of them. I think this one's going to be easier to plug in the y onto this one. So what is 4 minus 2? 2. So if this is 2, then every other side length also has to be 2. Perfect. All right, so, okay, find the measures of the numbered angles in a rhombus. Okay, cool, rhombus. So what do I know about the angles in a rhombus? Once again, opposite angles in parallelograms are equal. That's a given. The other thing that is important is that in a parallelogram, the diagonals, this diagonal is bisecting these guys. And if these guys are being, look, let's write that. If these angles are being bisected, notice how I put one arc on each of them. I didn't do this. Why didn't I do that? Because I know that opposite angles in a rhombus are congruent. So let's say this is 58, or let's say this is 60. This is also 60. And if 60 is being bisected, this will be 30. This will be 30. Well, if this is also 60 and it's being bisected, this will be 30 and this will be 30 as well. So I know for sure that angle 1 is 124 because they're opposite. 124. Now I know that this will be x, this will be x, this will be x, this will be x. So in order to find out that, okay, I could do that, or so I can do this. I could do 124 plus 124 plus x plus x plus x plus x equals 360. Or the other thing I could do, which is probably easier, is I know that adjacent angles in parallelograms are what? Supplementary. So that means this entire angle right here, which consists of what? 2x, right? This entire angle right here, which is 2x, plus this 124 is going to be supplementary. So let's just do that. What is 124 plus 2x equals 180 minus 124 minus 124. 10, 7, 56 divided by 2 divided by 2. What is that? 28, right? 8, yeah. Yeah, 28. So my x should be 28, and if my x is 28, that means that not only is angle 3 28, but so is angle 2. It's 28. Perfect. 2, 2, and then that 124 that was over here. Good. Okay. Find the measures of the numbered angles in the rhombus. All right, well, 2 is easy because we know that in a rhombus, the diagonals intersect. The diagonals bisect perpendicularly. So 2 is 90, perfect. Okay, so if this is 34, this one also has to be 34 because the diagonals in a rhombus bisect the angles. So now, once again, like we did before, this entire angle plus this entire angle equals 180. So let's put this is x, and now this is obviously 34. So it's pretty much just 34 plus 34 plus x equals 180. 34 plus 34 is what? 68. 68 plus x is 2x. 180. So this divided by 2, x should be 61. So x is 61, and if x is 61, measure of angle 3 is 61. What? Uh-oh. Oh! I'm tripping. Wait. What did I do wrong? Okay, well, I got the measure of angle 1 correct. So that's good. What happened here? Did I add something? Oh, I didn't do this. You guys are probably screaming, Mister, you didn't take this out. Oh my god. Yeah, so this is 112. Okay, there we go. Gotcha. So that means this is 56, right? There we go. Cool. See, sometimes I can go too fast too, so make sure you guys are always double checking your work, okay? So that was a big, I would have gotten that wrong, you know? All right, so this one, okay, LMNP is a rectangle, so I'm gonna automatically do that, a rectangle. LMNP, okay. Find the value of x and length of each diagonal. Okay, so now I know it's gonna have something to do with diagonals, so I'm gonna go ahead and write that. And I know that a rectangle's diagonals are congruent. So if this is congruent to this and they're both being bisected, then they're all gonna be congruent. So what else? Ln, this whole thing, is equal to this whole thing is equal to 10x minus 10, and MP, this whole thing, is equal to 7x plus 3. So let's make them equal to each other, right? Because the diagonals are equal to each other. The diagonals are congruent. So 10x minus 10 is equal to 7x plus 3 minus 7x minus 7x plus 10 plus 10. 3x is equal to 13. So x is 13 over 3. Okay. 13 over 3, perfect. And now we're gonna have to plug this back into just one of them. Why only one of them? Because I know that Ln and MP are what? Congruent. So let's just plug it into one of them. It's probably gonna be easier with tens for some reason. I just have a feeling. So let's do that. So 10x minus 10. So that equals what? Well, I have to plug it in. I have to plug in this first. So 10 times 13 over 3 minus 10. Well, this is going to be 130 divided by 3 minus 10 over 1. Remember, I like to work with fractions. So now, in order for this to be correct, I'm going to have to multiply this by 3 and multiply this by 3 as well, because I cannot add or subtract fractions unless they have the same denominator. With multiplying, it doesn't matter. Right here, I just multiply, it didn't matter. I just go straight across. But unfortunately, with adding and subtracting, they have the same denominator. So I'm going to have 130 divided by 3 minus 30 over 3, which is what? 100 over 3. So that means both of them should be 100 over 3. Perfect. All right, this is very important to know, guys. You got to know this. So let's see which one of these four will qualify for opposite sides or parallel. Well, opposite sides are parallel are for parallelograms. So if a yes is for parallelograms automatically, guys, then everything else will also be yes, because rectangles, rhombuses, and squares are all parallelograms. Okay, so rhombus, all of them, perfect. Opposite sides are congruent. Opposite sides are congruent. That's all of them. Okay. Opposite angles are congruent. Yeah, that's in parallelograms too. So they're all correct. All sides are congruent. That's not true. In parallelograms, only the opposite sides are true, not all the sides. So this is no. What about a rectangle? Definitely not, right? A rectangle has one side longer than the other. So the only ones that's true is in rhombuses and squares. So let's do, look, another one, okay? Diagonals bisect each other. Yeah, that's for every one of them. Why? Because it's automatic, because it is for a parallelogram. The diagonals are congruent. Okay, that's a little bit special. The diagonals are congruent in only squares and rectangles. So no, yes, no, and yes. Remember the example that I did with my hands for the diagonals of a rhombus? If I put a square with my hands, with my fingers, and I squish them together, one diagonal is going to get longer than the other one. So that's not congruent. Each diagonal bisects opposite angles. That is only in squares. Notice how squares, everything's going to be yes. Everything's going to be yes. Squares and I believe rhombuses. Yep. You see, guys, even I need to like think about it, okay? So just make sure that you guys are studying that. Diagonals are perpendicular. That's also in a square and a rhombus. Perfect. Not in these other ones. If anybody puts no for squares, then I just know you're not paying attention in class. So please, squares is always going to be yes, okay? So let's move on. Okay. Find the values of the variables for the parallelogram. Okay, so this is a parallelogram. What type of parallelogram though? It's a square. How do I know that? Because all the sides are congruent. How do I know that all the sides are congruent? Notice that they told me this is a parallelogram. So that means opposite sides are congruent. So if this is one tick mark, this is also one tick mark. If this is one tick mark, so is this one. And so it could either be a square or a rhombus, right? Because in squares and rhombuses is when you have all sides congruent. But this is a square. How do I know that? Because there's a right angle. A rhombus is a square without a right angle, okay? So once I see right angle, I can safely assume it is a square. So now squares, the diagonals bisect at 90 degrees. So this is 90. So measure of angle 1 is equal to 90. But it also says here, the measure of angle 1 is also equal to this. So measure of angle 1 is also equal to 90. So if this is equal to this, and this is equal to this, can't I say that both of these guys are equal as well? Yes, I can. It's transitive property, right? So I'm going to set them equal to each other. Why am I going to set them equal to each other? So that I can find the value for my y. Plus 14, plus 14. 4y is equal to 104. Y should be 26. Because I know 4 times 25 is 100, so I just got to add one more 4. So that's 26. Perfect, right there. So now let's go back and see if that y is going to help us. Okay, well, it's not really going to help us. But what do I know? Okay, so I know that in a square, the angles are 90. And what else do I know? That they're being bisected, right? Yeah, they're being bisected. So that means if this is 3x, whoops, then this is also 3x. So we just got to set 3x plus 3x equals what? 90. Because every angle in a square is 90. So what is 3x plus 3x? That's 6x equals 90. I think it's going to give us a decimal. 1 minus 6, 30. Oh no, it's 5. So it should just be 15. So x is 15. Perfect. And now same thing here. If this is 18z, so is this one. So 18 plus 18 is what? 36. So 36z is equal to 90. Okay. 36 divided by 90, 0, and then 1 minus 2 minus 78, which is 1, 2. Wow, it's really extra. I don't know why I'm doing all this. Yeah, I'm not gonna do all that. You guys can use your calculator. I probably messed up there, but just use your calculator, all right? If they asked you to type it as integers or decimals, an integer is not a fraction, so a fraction doesn't count, so you're actually gonna have to put it as a decimal. So just make sure you guys are plugging in. You could have plugged this in too. I was just having fun with division there, I guess. So let's move on. A, B, C, D is a rectangle, all right? So let's draw a rectangle. A, B, C, D. Find the length of each diagonal. This looks familiar. I feel like I already did this one, okay? So I know that AC is 3x minus 4. And BD is x plus 2. What do I know about diagonals in a rectangle? That they're congruent, just like they are in squares. So let's set this equal to each other. x plus 12 plus 12. So this is 2x equals 14. So my x should be, wait, did I do something wrong there? Oh man, what did I do? Oh no, I'm good. No. X is 7. So now if x is 7, we just got to plug it into one of them and then see which one is just one of them, because what do I know about diagonals? They're congruent. So if I find the length of one diagonal, I'll be able to find the length of the other one. So what is 7 plus 2? It's equal to 9. So they should both be 9. Perfect. Whoa. Okay. So let's look at this one. For what value of x is the figure a rhombus? So that means this value of x has to be something so that it is a rhombus. And what do I know about the side lengths of rhombuses? They're all equal. So we got to set them equal to each other. 7x minus 14 is equal to 3x plus 2. This is 4x is equal to 16, so x is equal to 4. That's it. Good job. All right, so for what value of x is the figure a rectangle? Well, a rectangle, and what are they giving me? They're giving me diagonal lengths. So what do I know about diagonals of a rectangle? They're congruent. So if all the things are congruent and they're being bisected, then they're all the same. So we just got to set them equal to each other. Equals 7x plus 22 minus 7x minus 7x minus 8 minus 8. 2x equals 14, right? 14. So divide by 2, divide by 2. Whoops. So x is equal to 7. Perfect. And let's look at this. Quadrilateral. Oh, look, we're on 6.5 now. 6.5. So a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent is called a kite. Remember, a kite looks like this. Congruent, of course, consecutive sides are congruent, not the opposite ones, like they were for parallel and the other ones that we're talking about. Okay, so a quadrilateral with exactly one pair of parallel sides, that's a trapezoid. Remember, guys, a trapezoid looks like this. Only one of the sides is parallel. Okay, find the measures of the numbered angles in the isosceles trapezoid. Okay, that's very important. What are the three properties we know about isosceles trapezoids? The legs are congruent, the base angles are congruent, and the diagonals are congruent as well. So here, I'm not really going to need to know the diagonal the diagonal knowledge, because I don't have any diagonals. Side lengths, I have no side lengths, but I do have base angles here. So if this is 52, this is also 52. Also, consecutive angles on the top of vertical, not these. These are supplementary. Why? Because look, if I extend it, what do they become? Same side interior. And same side interior angles on a transversal that cuts through parallel lines is supplementary. So what is 180 minus 52? 125. So if this is 125, this also has to be 125 because they're both equal to each other. What's 125? Oh, 10 minus 2 is 8. 128. 128. Okay, mid-segment. How do I know this is a mid-segment? Because my pieces are congruent. They were cut up evenly. So that means that this is the midpoint, and this is the midpoint, and this is a segment intersecting at the midpoint of opposite sides, so we call that a mid-segment. Now, the formula, which we should all know, the mid-segment of a trapezoid, is equal to half base 1 plus base 2. So let's do that. What is the mid-segment? It's 8x equals 1 half b1, b2, x plus 7 plus 68. This is what, 75, right? Right? 75? Okay. So this is a thing I didn't really go over in class because it didn't come up, but I'll go over it now. Remember, guys, that multiplying, look, if I do distributive property, I'm going to get 1 half x plus 75 over 2. I don't want to do that. That's going to make my life complicated, right? So remember, guys, multiplying by 1 half is the same as dividing by 2. So right now, this is being multiplied by 1 half, but it's also being divided by 2. So that means I can multiply this whole thing by 2. What is 1 half times 2? It's just 1. So if you can't see that way, then just see it this way. Instead of doing times 1 half, let's show it as divided by 2. How would we get rid of this? Wouldn't we just have to multiply by 2? So 16x equals x plus 75 minus x minus x. 15x equals 75. Which is what, 5, right? I think it's 5. Yeah, x equals 5. So now let's plug that into here to find the mid-segment. What is 8 times 5? 40. Find the measures of the numbered angles in a kite. Okay, well, remember, guys, in a kite, the diagonals intersect at 90 degrees. These angles are congruent, and the angles that are being intersected by the longer diagonal is actually bisecting the angles. Okay, so the shorter diagonal does not bisect anything. The longer diagonal does. So that means, let's erase some of this. Okay, so that means 1 is definitely 90. So 1 is 90. This, if this is 26, this also has to be 26. Okay, so now we can find this measure by doing what? The triangle angle sum theorem. So let's put this as x. So x plus 90 plus 26 equals 180. X plus 116, right? Plus 116 equals 180. Minus 116, 10, 7, 64? Something like that, right? 64, so x is 64. So this is 64. And remember, guys, these two angles right here are congruent. So if this is 64, this also has to be 64. Also, another way you could look at it is if we highlight, let's take this out. If we highlight this triangle is a what? Is isosceles, right? Look, this triangle is isosceles, right? Because of these tick marks. So what do we know about the base angles in an isosceles triangle? They're congruent. So if this is 64, this also has to be 64. 64, 90. Okay. We're almost done. Same thing. Another kite question. So let's look at this one. This is 90. This is 90. It's pretty easy. This is 25. Triangle angle sum theorem to find 4. So 90 plus 25 plus measure of angle 4 is equal to 180. I'm going to skip some steps. Measure of angle 4 would be 65. So this is 65. That means 2 also has to be 65 because of the isosceles aspect of a kite. The isosceles triangle that's within every kite. You actually have 2 isosceles triangles. So 90, 90, 65, 65, and then 25 for right here. Okay? Let's take a look at this. Find the value of the variable in the isosceles trapezoid. Okay, so I know this is isosceles, so I know that this angle and this angle, this angle and this angle are congruent, so let's set them equal to each other. 47 equals 2x plus 15. $32. So x is equal to 16. Perfect. Name each type of special quadrilateral that can meet the given condition. 2 pairs of parallel sides. All right, so rectangle and rhombus, that does work. 2 pairs of parallel sides. Rectangle and trapezoid, no. Trapezoid, no. Parallelogram, rhombus, and square. Okay, all of those work. Parallelogram, rectangle, rhombus, and square. So this one has all of them. So this is the right answer. And last one. For a trapezoid, consider the segment joining the midpoints of 2 non-parallel sides. So they're saying for a trapezoid, consider the segment joining the midpoints of the 2 non-parallel sides. So midpoint, midpoint, joining. How are its length? So how is this length and the length of the 2 parallel sides, this length, and this length, related? Oh, well, the mid segment is just half of the two parallel sides. So the length of the segment is half the sum of the lengths of the 2 parallel sides by the trapezoid mid-segment theorem. So this is the correct answer. So that's pretty much it. And I hope you guys study this weekend, at least on Sunday. So